So I am doing a sign test on Genshin Impact data, and I found this on the website activeplayer.io, which basically records up to millions of people who play games, and like it records the data. So I have these numbers, or well, I wanted to do it because I play Genshin Impact a lot. Like I have like a good 2,000 hours on it. So I really want to research stuff about it and see like if it actually holds true to my own opinions, because if it does, that means I can talk about it in game in people's faces who are in denial. And so the data is in millions of players because they record a lot of people. So so I have 12 samples, and the reason that we're using a sign test and not a mean test is because I don't have enough samples, because these kind of go by the month, so it collects the amount of players per month and not like actual whole values. So I have less than 30, and so because it's less than 30, then we cannot assume that my population is normal. And so yeah, the sample size was not 30 population. We can't discern that it's normal, but we can discern that it was taken randomly because they just record all the players that log on. And so because the sample size is too small, similar to other topics we had in the past where sample sizes were too long, back when we had the norm CDF and then the binomial function, we used the binomial when n times p, 1 minus p was less than 10. So that same principle goes into this. For this distribution, or for the sign test, we have to use binom PDF. And so, yeah. And we are testing or using the sort of value as the median. And so we're testing against the median. The median I chose was 15. And according to the median, or the median that I'm testing, because I believe that the median is different than 15, whereas a lot of people state it is around 15 million. According to the, according to like what everyone says, the median should be equal to 15. So that means 50% are below and 50% are above. But I am testing if that is different. More specifically, I am testing, oh my god, I'm only at 3 minutes. More specifically, I'm testing if the median is above 15. And so just to explain the HO, the HO, M equals 15 is basically the like the inherent like hypothesis that is like default. So when you state something, it has to be against the neutral hypothesis. That's why we say do not reject or reject, because it centers around the hypothesis. That's why we don't say like we accept the mean, because the mean is already accepted and it's the inherent value. So we're testing for this and the data. And so what we basically have to do is use the binomial distribution. And n is the number of values equal to the median, and p equals 0.5. This is the equation that we're using, the second equation. It is 1 minus binomial PDF and px minus 1. And we do minus 1 because the binomial calculates everything from the left. Like we had, when we were measuring like x less than or greater to equal than values, then we used binom PDF and CDF. And so binom CDF basically captures everything to the left. So then in equations like those, you do, for example, binom CDF, and then let's say your value was x less than 15, you would have to do binom CDF, the number, probability, and then 15, because it includes 15 in the sample. And so just to start our data right now, or that's basically how the binomials work. That's why we can't use a norm CDF, because first of all, it's the restrictions aren't applicable. And yeah, okay. So I recorded my data, and I put it in millions, and I already did addition and subtraction, or like the plus and minus, so I'll just read out like the full scale. It's around 16.107 million, 18.832 million, 23.826 million, 19.775 million, 14.515 million, 15.202 million, 23.213 million, 23.986 million, 14.627 million, 15.993 million, and 12.361 million, and 14.779 million. So when we count those all up, we get our n, which is the number of the number of tests that we basically did, or more specifically, the numbers that aren't equal to the median, because if it is equal to the median, then that wouldn't really help the hypothesis test because the value is equal to the median. So what you first want to do is you write down all your values. I simplified them because they are kind of long and I didn't want to write 23,213,841 and make that a bunch of times. So basically, you want to count, or you want to put a plus or minus, or just mark down which values are above or below the mean. If it is above the mean, then there would be an addition symbol. So let's count how many values I had above the mean. So I had I had 8 values above the mean and 4 values below the mean. So if a number was equal to the mean, then you can't count that, or you don't necessarily include that in the sample, because it's already like with the median. Sorry. Okay. So once you mark these, you want to write down your hypothesis, and as I said before, m standing for median, m equals 15, and we're testing if m is greater than 15. You want to write down all your pluses and minuses, and to find the test statistic, it's basically x, and it equals the number of data values greater than m, and greater than m is basically the plus sign. Even if it's equal to the median, you can't put it, so you only count the ones above that, and then that is your x value, right? And then since I am testing if the median is greater, there are numerous equations that you can use for this. It's binom CDF, because PDF is used for like single values, so CDF accounts for like a range of values that you're trying to find. So usually the equations are binom CDF and 0.5x. That's how it mostly goes. For median is greater than, it's 1 minus binom CDF and 0.5x minus 1. And then the last one is 2 times the second equation if x is greater than 0.5, then 2 times the first equation if x is less than 0.5n. Now basically you want to put these values into the calculator. 16.1, 18.8, 23.8, 19.8, 13.5, 15.2. I'm almost done. 14.6, 16, 12.4. Well, actually, I don't know why I did that. You don't need to put in your calculator. I take it back. But yeah, basically all you have to do is plug it into the equation. So we're going to put 1 minus, and then we're going to go second, vars, and then we are going to go scroll down all the way to binom CDF. And trials, we had 12 trials. Our p-value is always 0.5 because binomial, half above, half below the median. And then our x minus 1, so values greater than 1, and our values were 8 total, so that is 7. then you get your binom PDF. And for me, I got 0.19. And because my significance level was 5%, that means I failed to reject the claim that the median is larger than 15 because 0.19 is greater than 0.05. So we fail to reject the median. We do not have sufficient evidence to conclude that the median is greater than 15. And anything else I missed? Yeah, there you go. That's all.